Hello everybody, today myself KJ Kumar, I am from Mechanical Engineering. Today I am explaining about sample space events of a random experiment. Introduction to random experiments. Random experiment is a process that produces an outcome that can be precisely predicted. These experiments get foundational in the field of probability and statistics. Examples include flipping a coin and rolling a die for drawing a card for a deck. Random experiments. A random experiment is a process which produces outcomes. If we toss a fair coin, we obtain either a head or a tail. So losing this fair coin is an experiment which can produce those two outcomes, either head or tail. A random experiment is a process to produce an outcome that could be precisely predicted. These experiments are foundational in the field of probability and statistics. Example include flipping a coin and rolling it or drawing a card from a deck. An amble and a random experiment is a process which produces outcomes. It's understanding sample space. Sample space is a set of all possible outcomes of random experiment. It is typically denoted by the symbol S. For example, when flipping a coin, the sample space is head and tail. Sometimes it will be head and sometimes it will be tail. But we can't decide how it will be head or tail. Sample space is a set of all possible outcomes of an experiment. Two coins are tossed, make the sample space for the experiment by making a list, a table tree diagram list, head, tail, head, tail. And the tree diagram, head becomes to head, tail becomes to head, tail. And the outcome is head, tail, head, tail. The sample space is head, tail, head, tail. Therefore, we include the table. The table belongs to head, tail, head, tail. The sample space of a random experiment are typically denoted by symbol S. For example, if flipping a coin, the sample space is its tails. Sample space can be either finite or infinite. A finite sample contains a limited number of outcomes, while an infinite sample space is unlimited outcomes. For example, rolling a die has a finite sample space of 1, 2, 3, 4, 5, 6. A sample space is that are possible outcomes in an experiment. Suppose two coins are tossed, and the one is for the experiment head and another one is tail. Suppose if the list of the outcomes are head, tail. We can't decide how it will be head or tail, and it can decide by the coin. Sample space can be finite or infinite. It will be tossed and head become head, tail become tail. We could tree diagram for experiment by making a list and table a tree and diagram. Events different. An event is specific outcome or a set of outcomes for sample space. Events can be simple one outcome or compound multiple outcomes. For example, getting an even number while rolling a die is compound event 2, 4, 6. For example, getting another even rolling a die is known as 8, 10, 12. Maybe it's make approximate 14, 16, 20, 22. Sample space and events. An experiment is any action or phenomenon whose outcome is subject to analysis. An outcome is the result of an experiment. Each run of an experiment results only one other. A sample size is also a set of false possible as of an experiment. An event is a subset of sample space. An event occurs when outcomes belongs to the it occurs a sample space or elementary event. It is a subset of sample space that has only one outcome. An outcome from the sample space it is denoted by the letter S. For example, getting an even number while rolling a die is a compound event. The 2, 4, 6 and the even numbers and when the die was rolling an even and the odd numbers were 9, 3, 5, 7 and something 9. The types of events. Events can be classified into different types or sometimes another events, the difficult events, independent and dependent, mutually exclusive events, something random experiments. The all will be frequented and equally and equality and inequality. Independent events do not affect each other's outcomes, while dependent events do. Mutually exclusive events cannot occur at the same time, like rolling a die and getting both a 3 and a 4. Types of events and probability. Dependent events do not affect each other outcomes while dependent events do. Events can be classified into different types such as independent, dependent and mutually exclusive. Independent events do not affect each other's outcomes while dependent events do. Mutually exclusive events can occur at the same time, like rolling a die and after getting a both die in 3 and 4. The only complement of an event. This complement of an event is donated A by N, including all the outcomes in sample space more than space that not in A. These concepts help in calculating probability of events not occurring. For instance, event A is a rolling number greater than a 4 is then a rolling a number less than or equal to 4. Less than equal to 4. Components of all events. These components of event A is defined to be event for all sample points that are not in A. The complement of A is denoted by A. Event A, Venn diagram and sample spaces. The complement of event A is defined by considering of all sample points that are not in A. Probability of events. The probability of event is a measure of the likelihood that even event will occur. Probability of favorable outcomes are discounted by the sample space. It is calculated as the number of favorable outcomes divided by the total number of possible outcomes in the sample spaces. For example, the probability of rolling a 3 on a die is 1 by 6. Probability of an event is measure of the likelihood that the event will occur. Remember, probability is a number of just not a set. Mathematically speaking, the probability of an event is denoted by P of E is P of E equal to N of E by N of S. Recall that N of E is cardinal number and set E and N of E is cardinal number of set of S. These events are mutually likelihood and some sample spaces. It is calculated as the number of favorable outcomes divided by a total number of possible outcomes in the sample space is equal to f of E by P of E is equal to T of F. For example, probability of rolling a 3 on a die is 1 by 6. Probability of an event is a measure to the likelihood that the event will occur. Remember, the probability is a number of just the not a set. Mathematically speaking, the probability of an event is equal to P of E. Visual representation of sample spaces. Sample space can be represented using visual tools such as Venn diagrams or trees. Suppose there are examples shed 1 and shed 2, pant 1 and pant 2. Socks 1, 2 and socks 2 and socks 1, socks 2 and socks 2. Two shirts, pants 1, 1 pant, shoe shirt, socks 2, pant 1. There are the shirt 1, pants 1 and socks 2, pants 1, pant 2. Here about the figure and the representation help in understanding the relationship between different events. For an example, Venn diagram can illustrate the intersection of two events. Sample spaces can be represented using the various visual tools such as Venn diagram and or diagram trees. Practical applications. Understanding sample space and events is crucial in like finance and science and engineering. These concepts help in making informed decisions based on probability. For example, probability models can predict the likelihood of stock market trends. Sample space and events. Basic concepts and probability. Experiment any action or whose outcome is subject to uncertainty. Example, tossing a coin that pH value on somebody and counting the number of customers visiting a store in one sample space. The set of all possible outcomes of an experiment usually denoted by S. Those about 3 examples. The spaces are toss, tail, and head, and those are and 0, 1, 2, and so on respectively. The conclusion. Sample space and events are essential components of Probability theory. Mastering these concepts allow for better analysis and understanding of random phenomena. Ultimately, then further basis for more complex statistical methods and applications. Sample spaces and events. Experiment in action or phrases it can be used and so on and respectively. Thank you.